Hello, and welcome to a lesson on natural logarithms. So before we start, we're going to do just a little bit of a warm-up. If I wanted to solve 10 to the x is equal to 32, how would I go about doing that? I would rewrite it using logarithms. So we use logarithms to solve for an exponent. So x would be equal, because x is my exponent, log base 10, and remember we don't write base 10, because base 10 is assumed on a log, 32. So that would be how I would rewrite that, and I would type that into my calculator to make sure that works. So log 32, 1.5. So that would be my answer for that one. So now we're going to look at another type of log that doesn't have a normal base written underneath it. Not really anything way too different. We're going to look at E, which has very common applications in the medical world, in the financial world, in science. It's used anywhere that there's a continuous growth. And what I mean by continuous growth is this fancy part right here is part of your common interest formula, or your interest formula. So what we want to do is N represents time. So I want you guys to think about this in terms of time. If I did this once a year, so N is equal to 1, that would look like this. 1 plus 1 over 1 to the 1 power. What's the answer to that? 3, 2, 1. It's 2. There you go. Haha, you guys thought I was going to put that 1. I gotcha. What if I did it twice a year? And you guys don't know what I mean by this yet, but you guys will get to it whenever we do. But if I made N equal to 2, and I plug that in, I get 1 plus 1 over 2 squared, which is 3, 2, 1, 2.25. Now if I keep making this N number bigger and bigger and bigger forever and ever and ever, eventually it will start to approach this number. Just for future reference, this is called a limit. You will see it a lot in math analysis and a ton in calculus. So get used to that symbol right there. So just like pi means 3.14, E means 2.71828 going on forever. So it's just a normal number. Now, when I'm dealing with E, I'm going to treat it just like I am normal exponents and logarithms, because that's where I'm going to see it the most. So let's go ahead and look at the graph of this. If I plug in 0, I get e to the 0, which is 1. If I plug in 1, I get that fancy little number I had on the last page, 2.71 or 72818. That number right there. So I'll put 2.72. Alright, and so that's going to look like this. At 0 it's 1. At 1 it's 2.72. So that's going to be a graph that looks like this. Why doesn't it ever touch the x-axis? 3, 2, 1. Because if I make it negative, it's just going to be a fraction. It's just becoming smaller and smaller fractions, but it's never actually going to hit 0 or become negative. Alright, logarithms we've talked about already are the inverse of exponentials. So if I want to graph this logarithm, I'm going to use the inverse coordinates. So the natural log of, so whenever I plug in 0 for x, I got 1. So whenever I plug in 1 for my natural log, I'm going to get 0. We've talked about that already. Anything to the 0 power is 1. What's going to give me e? The exponent's got to be normal, so it's going to be 1. So I'm going to treat these as my x-coordinates. Sorry, that should be inverse. So I'm going to treat these as my x-coordinates right here. These are my y-coordinates. I'm going to start graphing them. 1, 0, and 2.72, 1. So here's my graph right there. Just like my exponential graph never touches the x-axis, my logarithmic graph never touches the y-axis. So, continuing to move on. All right, let's see how we use this in just the basics right here. My notes got messed up. There we go, fixed. All right, so we need to learn how to read e's and their inverses, which are natural logs. So let's start with this example. E to the fifth, or e to the x is equal to 5. So I want to figure out which exponent would give me 5 if I plug it in there for e. So the way I'm going to solve this is I'm going to use logarithms. Anytime I want to solve for an exponent, I use logarithms. So you guys are used to writing that like this. Log base e of 5. But we don't write log base e. Instead of log base e, what we're going to do is we're going to write the natural log. Natural log means log base e. Okay? So you guys are going to see that ln quite a bit. It means log base e. Alright? And just like normal, I can type that in my calculator. Natural log 5. The exponent that is required to get 5 using e as my base is 1.6. So I'll verify that. E to the 1.609 is 5. So you guys can see that works. Okay, so let's do a couple of these examples. Natural log of 4, I can just type that in my calculator. Alright, so now I'm going to ask you guys to do a couple of these problems. You can treat these as x's. And I want you guys to rewrite these using exponential forms and logarithmic forms. So go ahead and pause the video. 5, 4, 3, just try problem 1, 2, 1. Okay, so you should have rewritten this as 4 equals e to the x. Okay? If you haven't already, try the other 3. 5, 4, 3, 2, 1. E to the x equals 0.5. The 2 equals the natural log of 6x. And negative 1 equals the natural log of x squared. Alright, so moving on. The power of inverses. So logs and exponentials, they're inverses, they undo each other. E and natural log undo each other. So in this example right here, or in these couple examples, I'm going to use this property right here. So e to the natural log of x is just equal to x. So the answer to e to the natural log of 7 will be 7. If you don't believe me, we can use some simple math to check that. So I'm going to put an x over here, and I'm going to rewrite this in logarithmic form. So my base is e, so I'm going to rewrite this as the natural log. My answer is x, or my argument is x, and then my exponent is natural log of 7. Do you guys see how this comes out to be 7? Alright, why don't you guys go ahead and try example 2. Don't pause the video too long, because I'm sure you guys can figure it out pretty quick. 5, 4, 3, 2, 1. Using this property right here, this is just equal to 4x plus 3. Alright, so equations involving base e. If I want to solve for x, I'm going to use what operation solves for an exponent? 5, 4, 3, 2, 1. Logarithms solve for exponents. So x is going to be equal to the natural log of 7. And I asked you to solve these, so I want you to plug that in your calculator. Natural log of 7, 1.9459. All right. Why don't you guys go ahead and do 2 and check your answer in a second. 5, 4, 3, 2, 1. Hope you guys didn't forget order of operations. Divide by 5. E to the negative x is equal to 2 over 5. solving for an exponent, so I'm going to use a logarithm. Natural log of 2 over 5 is equal to negative x. So I'm going to type that in my calculator and see what happens. Natural log of 2 divided by 5 is negative 9.16, but whenever 9.163. So negative x equals negative 0.9163. So x is equal to 0.9163. All right, why don't you guys give 3 a shot? Pause the video. 5, 4, 3, 2, 1. All right, I'm going to start by subtracting 2. 3e to the x is equal to 2. Divide by 3. E to the x is equal to 2 over 3. Use logarithms to solve for the exponents. So the natural log of 2 over 3 is equal to x. And then type that in my calculator. That's not what I wanted. Try again. My answer is negative 0.4055. Alrighty. So this time I'm giving you guys some natural logs. I'm asking you guys to solve for those. So natural log of x is equal to 9. If I want to solve for x, I'm going to rewrite it in exponential form. X is equal to e to the 9th. Type that in your calculator and get your answer. Natural log of 5x equals 4, so 5x equals e to the 4th. Divide by 5. X is equal to e to the 4th over 5. Type that in your calculator. You got your answer. How am I going to handle 3? Natural log of 3 plus the natural log of 5x equals 8. Go ahead and pause the video. Give that one a shot. 5, 4, 3, 2, 1. Okay. It's addition and it's logarithm, so I'm going to multiply 3 times 5x. So natural log of 15x equals 8. Rewrite it in exponential form. 15x equals e to the 8th. X is equal to e to the 8th over 15. Don't forget to type in your calculator and get your answer. All right. Last little example here, and then I want you guys to go ahead and practice some worksheets. I'm going to use the property of logarithms that when I'm adding, I multiply them. So x times x minus 2 is equal to the natural log of 15. I have the same log on both sides, so I can cancel them out. X squared minus 2x equals 15. X squared minus 2x minus 15 equals 0 because I have a quadratic and I want to solve. X minus 5 and x plus 3 equals 0. So I get x is equal to 5 and x is equal to negative 3. That's my answer, right? 5, 4, 3, 2, 1. Hopefully you guys said no because negative 3 does not work. Remember, I can't have a negative argument. If I plug negative 3 back in, I got negative 5 there, which obviously doesn't work as well as with the rest of the natural log. All right, go ahead and get some worksheets. You guys have a quiz next class. I will be here tomorrow, so come see me in Math Lab tomorrow, room 208. All right, good luck.